Student, how are you? I am Arun sir, qualification bachelor of engineering from Jadavpur University. Welcome to my channel Tuition Expert. Today in this class I will discuss you the equation of projectile trajectory. Now let's start about the class. Equation means the path. Equation contain x and y. So we take this is x axis, y axis. Suppose a particle is projected with velocity u at an angle theta, then what is the trajectory of the parabola? What is the trajectory of the projectile path? The projectile path will be this way. This way. The projectile path will be this way. So take a point on the path is x, y. Take a point whose coordinate is x, y. So what is x? What is x? This is x. Okay? This is x and this is y. We know the coordinate of a point P is this. Now the particle is projected with velocity u. So the component of this along this equal to, we know, u cos theta, and from this vertical component u sin theta. Now let the time taken to reach the particle from this point, that is point of projection, to that point is t. T is time taken. What is t? Time taken to reach at point P. Okay. So what is x? Now we know the acceleration due to gravity act completely vertical and downward. There is no component along horizontal direction of the acceleration. So here we can take g equal to 0 along this. Here means along this direction g equal to 0. That is no acceleration along the horizontal direction. So we can write x equal to distance equal to uniform velocity u cos theta into time taken t. This is x coordinate. Okay, this is the coordinate of x, and y we can write y is along vertical direction. So y equal to, we use this formula. For y equal to, we use this formula. So here y, u is vertical direction and velocity is this is ay actually, ay. So uy equal to u sin theta t minus half ay is g t square. So these are the two equations. To get the equation of projectile trajectory, we have to eliminate the t. So from this equation we get t equal to x by u cos theta. Now put here t. Now put t is at here. We get y equal to u sin theta into t. This is equal to x tan theta minus half g x square by u square cos square theta. So this is in the form of ax minus b x square. So y equal to, we know y equal to ax minus bx square. This is the equation of parabola whose opening is vertical downward. If the negative sign is at here, that is we take common minus. So this is the parabola whose openings along vertical downward. So this is the vertex of the parabola and openings vertical downward. This is the equation of parabola. So projectile path is always parabolic equation. I repeat once again. Coordinate of this point is xy, so x equal to velocity into time, because velocity here no acceleration is present at this direction, so this will be velocity into time, and along y direction there is acceleration acts in opposite direction, so this equal to, we use y equal to ut minus half gt square. Okay, so here acceleration is minus g, vertically act opposite to the direction of movement. This is the velocity direction, acceleration acts opposite direction, so we put here minus g. Now from this point, now we have to eliminate the t, because equation, for finding the equation we establish the equation in terms of x and y, so we have to eliminate t equal to x by e cos theta. From here we get and put t at this equation, so equation becomes this. Now this is we take at a, and from this and this we take as b. This is a, this is b, so the equation is ax minus bx square. Y equal to x minus bx square, that is take common minus bx square. If coefficient of x square is negative, then the parabola is vertical downward, opening of the parabola is vertical downward, so this is the equation of parabola. The projectile path will be parabolic equation. If we want to write the equation in terms of range, if we want to write this parabolic equation in terms of r means range, so y equal to this. Now take common x, what is r equal to e square sine 2 theta by g, this is r. So now take common tan theta from this. This sin theta by cos theta, you get sin theta cos theta. So now 2 is at here, and g by g, from this to this we can shift this. So what is this? U square sin 2 theta by g is r, so this is u square sin 2 theta by g, this is r. Problem, yeah, one problem. Equation of a projectile path is given by y equal to this. Find the angle of projection and initial projected velocity. This is the question. Now to solve the problem, if you cannot remember the equation of projectile trajectory, then just you now input. Now if this is u, this is theta, then this component is u cos theta and this component is u sin theta. Now this is the projectile path, so now this one is xy, so this time is t, so x equal to u cos theta into t and y equal to u sin theta t minus half gt square. You don't have to remember the formula of equation trajectory. General student cannot remember the formula, but if we can use this, we can easily use this formula, x equal to velocity in time and y equal to this. So just eliminate t from here. So y equal to u sin theta x by u cos theta minus half g into t So this is the equation of projectile equation. So you don't have to remember the equation, just write the two equation and eliminate the d. From this you get the equation of projectile trajectory. So here the equation is y equal to x tan theta minus half x square by u square cos square theta. Now comparing this equation with this, so this and this 1 and 2, if we compare, comparing 1 and 2, we get what is tan theta equal to 2, tan theta equal to 2, so theta equal to tan inverse 2. Now phi equal to this, here coefficient of x square is this, and here 5, so 5 equal to g by 2, that is 5 cos square theta. So we can write e square cos square theta equal to 1, so tan theta equal to 2, u square equal to 1 by cos square theta, which is sec square theta equal to 1 plus tan square theta 1 plus tan theta equal to 2, so u equal to 5. So this is the problem related to equation of projectile trajectory. Now one question related to this. Now what is the radius of curvature at highest point of projectile trajectory? For that we use, if the path is circular path, and here we know that tangential acceleration and normal acceleration, two acceleration is present for the circular motion. In circular motion, if a body moves with non-uniform velocity, that is variable velocity. If a body moves with variable velocity, then at and an present. Now that if the velocity at any point is v and radius is r, we know the normal acceleration is present. For normal acceleration is given by v square by r. So we use, so to find the radius we use the formula. We use that formula, r equal to v square by an. R equal to v square by an. We use this formula. Now in trajectory of projectile, what happens? This is u, this is theta, so this is u cos theta, and this is u sin theta. Now velocity at highest point, what's u cos theta? Because velocity remains same at all point. Now what is the acceleration? Acceleration along normal direction. Here velocity in this direction and acceleration in this direction. We have to take normal acceleration. So here velocity is and acceleration along this only g. So we get radius of curvature at that point, highest point, radius of curvature at that highest point equal to u cos theta whole square by g. This is the answer. Sometimes in MCQ this problem comes. So use this formula to get the radius of curvature at the highest point. Now this is the end of the class of equation of trajectory. Now this is the end of the class. Students, subscribe my channel to get more video. Okay, thank you.